Hi, welcome to my video on the area of a sector. I'm going to use the three circles that's here to illustrate the different parts of the circles down below that we're going to use to find the area of a sector. O is the center of each circle. O is the center of each circle. A central angle, an angle formed by two radii and the vertex at the center of the circle. So angle AOB is a central angle, two radii and a vertex at the center. XOY is a central angle with OXOY radii with the vertex at the center. And angle POQ is a central angle. OP and OQ are radii and O is the vertex at the center. And in circle A, we have an acute angle is this one, is less than 90, so it's the angle AOB. We also have another one, that's the other part of the, makes up this one. And we also have to call it angle AOB, but it's a reflex angle. It's an angle between 180 and 360. So if this angle here is 100, then this one is going to be 260. In circle B, we have angle XOY is the acute one, and the angle XOY, so this is the acute one right here, XOY, and XOY, this one right here is the reflexive. Again, the two of these add up to 360. And POQ, angle POQ is the acute one, and the reflex one is the POQ. And we have to name the two of them with the same letters. Now, an arc of a circle. An arc is a part of the circumference. So in circle A, this is an arc which is a part of the circle. So it's the arc AB, and it's with a stroke or an arc over the top. Or we could have this arc ACB. ACB. That's an arc. That's a part of the circle. Or we could have AC as an arc. As long as you travel along the circumference of the circle from one point to another. Or we could have the arc BC. So there's many arcs in circle A. And also in circle B, we could have the arc XY right here. Or we could have the arc WY. Or WX, or we could have XWY, so there's many arcs on a circle. As long as you have 2 points on the circumference, you'll have an arc. And in circle C, we have the arc PQ, just naming a few. PRQ is this arc right here. Or we could have the arc QR. There are many, as you can see, many arcs. But of all the ones we named, the arcs can be named as minor or major. A minor arc is part of the circumference whose measure is less than 180 but not 0. And you only name a minor arc with 2 letters. So in circle A, the minor arc is AB. Because this angle here, if you move very straight on across, this is a 2 radii, this is diameter. So this arc here is less than 180, so it's the minor. If you go with this arc here, AC, you could have AC as a minor arc. You could have BC as a minor arc, and you name it with 2 letters. Circle B, a minor arc would be XY. It could be WY, or it could be, again, close, right straight across would be diameter, so WX could be a minor arc. So a minor arc is named with 2 letters. And in circle C, a minor arc could be PQ, it could be PR, or it could be RQ. but I can't go this because, again, if you draw this diameter right straight across here, then this arc here is right straight across is 180 as far as here, so a little bit more. So that makes it what we call a major. Anyway, the second part, a minor arc is less than 180. A major arc is part of the circumference whose measure is between 180 and 360. And we name a major arc with 3 letters. So in circle A, a major arc would be A, C, B. Arc A, C, B. 3 letters. And in circle B, the major arc would be X, W, Y. X, W, Y, major arc X, W, Y. And in circle C, a major arc could be P, R, Q. I'm only naming a few of them, but not all. But I'm naming with 3 letters on the arc. A major arc is named with 3 letters. It's an arc that has a measure of more than 180 and less than 360. Let's continue. Every circle I draw on most of these pages, I name O as the center of the circle. Now, we have the measure of the central angle is equal to the measure of the intercepted arc. Let's explain. In the circle D here, we have the arc TR, which is this one, this is the arc TR. So that arc, notice is an arc TR is 110 degrees. That means if this arc is 110 degrees, that means the central angle is the same measure. So the angle TOR is 110 degrees because the arc and the central angle is the same measure. So this central angle TOR is cutting off this arc right here. So these 2 angles, the angle and the arc, are the same measure. And so if this arc here is 110, that means this other arc, 360 all the way around the circle, so 360 minus 110 gives me 250 degrees. So the TV, this arc TVR, this arc is 150 degrees. So that means the angle TVR, which is this one, is 250 also, because the intercepted arc and the central angle are the same measure. Let's move on to E. It says we have a circle, angle GOH. GOH is the angle. Notice this angle is 150 degrees. That means if this central angle is 150, that means the arc GH is 150 because they're the same measure. And that means that if that's 150 right here on this arc, that means this arc is 360 minus 150. So it's a 210. So 150 and 210, so this arc here is 210 degrees. So 210 and 150 is 360 all the way around. So this angle in here is 210 because this is a reflex angle. And so if you add the 2 of these up, 110 or 210 and 150 makes 360. If you go all the way around a circle, you get the 360. F, we have the arc JL as 120, JL. So this is the arc JL. Note this is the measure of the arc. So this arc is 120. And if you notice, we have a radius, and a radius, but these 2 radii are joined together, so that's a diameter. And that diameter forms a straight angle. So that straight angle there is 180 degrees. So that means that this is a semicircle. So that means this angle, or this arc right here, is 60, because 60 and 120 makes 180. So the angle JOL, well, the central angle is 60. So, sorry, the arc is 120, so the central angle is 120. And if this is 120 and this is 60, put 60 in. That means this angle in here is 60 because the central angle is the same size as the arc. So LOK is 60. And JLK. So that's from one side. This is the diameter. So this is 180 degrees. This is a semicircle, half the circle. And that means the measure of JMK. So if that's 180, this is the other half. So that's 180. That arc is 180. That means that this angle right here is 180. Let's continue. We have a circle. We have an angle of 110. We have an angle of 120. So what's the measure of angle AOC? Well, all together, if you think about it, we got 120. We got 110. That's 230. So 360 is all the way around. So 230, subtracted from that, is 130. So this angle here is 130. 360 around the center. And that means, what is it's 110, 120, 130. So the arc FA is equal to the central angle, so it's 110. So this arc, the arc FC, so this angle is 120, this arc is 120. Because the central angle and the arc have the same measure. And the arc CA is 130 because it's the same as the central angle. And what about the arc, again is arc, AFC. AFC is 120 plus 110 is 230. And what about the arc FAC? FAC is these two arcs joined together. 110, 130 is 240. So again, just different angles. And remember, the central angle and the arc that it cuts off is the same measure. And let's go to H and see what we have here. We have a circle, O is the center, and we notice that this angle is 40. But we notice that this OY is equal to OX. You have to notice that because these are the radii of a circle, and all radiuses of a circle are equal. And we know that in previous videos that if these two sides are equal, then the angles opposite those sides are equal. So if this angle is 40, that means this angle is 40, because these are the two angles opposite. So this angle 40 is opposite this side. This angle 40 is opposite this side. So these two angles are equal. And in a triangle, we got 180 degrees. We got 40 plus 40 makes 80. So these two angles make 80. So if we subtract, we get 100 degrees. So this angle at O is 100 degrees because 180 in the triangle. So the angle OYX we have is 40. Let's fill that in. The angle XOY is 100. Let's fill that in. So if this angle is 100, that means this arc out right here is 100 because they're the same measure. And if this arc is 100, then all the circle is 360. So 360 subtract 100 gives you 260 degrees. So this arc from here all the way around to here is 260. Let's continue. We're going to use that to help find the area of a sector. All these ideas. Partial area of a sector. Partial area means a sector is the partial area of a circle, part of the area of a circle. It is the area enclosed by two radii and an arc, which is part of the circumference. So we have this shaded region. So these are the two radii, OB and OA, and this is the arc. So this area is enclosed by these two radii and this arc. So this is a sector. Sector AOB is a part of the whole circle. And we know that the measure of this arc, this is the arc AB, the central angle, AOB. So this angle here, the measure of this angle and the measure of this arc are equal. So the area of the sector, AOB, this area here, is the central angle divided by 360 times the area of a circle. Because the central angle is a fraction of the 360, so it's a part of the area. So it's the central angle over 360 times pi r squared. So this is the formula for the area of a sector when we were given the central angle and the radius. So let's go and work some out. Find the area of each sector to the nearest tenth. O is the center of each circle. So we have, find the area of the sector XOY with the 60-degree angle. So the area of a sector is the central angle over 360 pi r squared. And the central angle that we're trying to find, the central angle is 60 that we're given over 360. And pi is 3.14. And the radius of the circle is 20. So the OX or OY, either one of them is 20. So that's a 20 squared. And if you work all that out on your calculator, you punch in, you can cancel these out. You can go 1 and make that a 6. So you got 1/6. So you can go 1 divided by 6, hit enter, multiplied by 3.14, multiplied by 20 squared, or 20 times 20. When you do, you get a 209.33. And it says to the nearest tenth, so it's 209.3. And it's in meters, so it's square meters. So there's the final answer. B, let's work out the area of the shaded sector now. So notice I'm not finding the area of this piece here, just this. So if the arc ACB is 200, this arc is 200 degrees, that means that this central angle, right here, this angle is 200, because the measure of the arc and the central angle intercepts this arc. So the area of the sector, let's write down sector, is central angle over 360 pi r squared. I always write down my formulas. The more I write them down, the more I remember them. And the central angle in this case is 200 over 360 times pi, which is I always use 3.14. And the radius is 6 centimeters, so that's 6 squared. And if you want, you can cancel the zeros. 4 into 20 goes 5, 4 into 36 is 9. So we use our calculator. We go 5 divided by 9 and hit enter, and you get an answer. And you multiply by 3.14 multiplied by 6 squared, or 6 times 6, and your answer comes out to be 62.8. And it's dead on, there's no rounding. And it's centimeters squared, because it's area. Area is 2 dimensions, so it's square. C, let's work this one out for the area of a sector. We have the arc is 280 degrees. So arc ABC. ABC is 280 degrees from here all the way around. If that be the case, then the arc AC must be 80, because 360 all the way around, subtract 280, gives us 80 degrees. So the arc AC is 80. That means my central angle is 80, because the central angle is intercepting this arc, so the arc and the central angle is the same measure. So the area of the sector is central angle over 360 pi r squared. The area of a circle, so the central angle is a fraction of the circle. So the central angle is 80 degrees over 360. Pi is 3.14. And my radius OA is 10. So it's 10 squared. You can cancel the zeros, same as dividing by 10. 4 into 8 goes 2. 4 into 36 goes 9. So I have 2 divided by 9 times 3.14 times 10 squared, or 10 times 10. And that gives me 69.777. And we want to round that to the nearest tenth. So 69.8, because that 7 is in the 10th place. So these become zeros. So because that's a greater than 5, we add 1 on the 7, make 8. So these are all zeros on the right side. And that's in inches, so it's square inches. So the final answer to the nearest tenth. And let's continue. Oh, practice. Practice means you pause the video, you work out this answer, and press play to see if you got it right. And do that for each question, and see if you're doing it okay. Here we go. We have a circle whose radius is 3. Find the area of a sector whose central angle is 36. Well, just draw a little diagram. We have a circle, and we have a radius. We have a center. The radius is 3, and the central angle is 36 degrees. So let's make it 36 degrees. So the central angle is 36 degrees. So this angle right here, O is the center. This angle is 36. That means, just as a little sideline, that arc is 36 degrees. So to get the area of, I'm going to shade it in, to get the area of this sector right here, it's the area is of the sector is central angle over 360 pi r squared. Central angle is 36 over 360. Pi is 3.14. And the radius is 3, so it's 3 squared. And 36 divides into once, and that gives me a 10. So I got 1 divided by 10 times 3.14 times 3 squared, or 3 times 3. And that comes out to be 2.826, and to the nearest tenth is 2.8, and it's in centimeters, so it's centimeters squared. So there's the final answer. Remember, the tenth is the 8, so this number here is less than 5, so we put zeros for these, and we do not change the 8 because it's less than 5. Let's go on to do number 2. Remember, pause the video and work with this answer. We have a circle, we have a shaded, this is a sector, 2 radii bounded by this arc. The diameter is 10, so if the diameter is 10, that means your radius is half of that, so the radius is 5. So that's a 5. And this arc, notice the arc is FHT. FHT is this arc, so that means the central angle is 150. So this angle here is 150 degrees. So the area of the sector is central angle over 360 pi r squared. And the central angle is 150 degrees over 360 times 3.14, and the radius is 5 squared. We cancel the zeros. We can divide each of these by 3, so we get 5 and 12. Divide by 3, yep. Now we go 5 divided by 12 on the calculator. 5 divided by 12 times 3.14 times 25, or times 5 squared, and that gives us 32.708. And to the nearest tenth, it's 32.7, and it's in feet, so it's square feet. Again, this is in the tenth place, so this number right here is 0. 0 is less than 5, so these two numbers become 0, 0, and we do not add anything on the 7, so 32.7. And we have number 3, the last one. Pause the video and work these out. Let's see. It says we want the area of this sector here bounded by this radius and this radius, so this one right here. So we need either this arc or we need this angle. So here we go. It says the measure of angle YWO. YWO is this angle right here. So this angle is 30. And if that angle is 30, we know that the two radii of a circle are equal. That means if two sides are equal, two angles are equal. So that means that angle is 30. The angles opposite the two equal sides are equal. 30 and 30 make 60. So this angle right here is 120. So 180 minus 60 is 120. So if this angle is 120, that means that this angle over here on this side, which is belong to the sector we want, is the 240. So the central angle that we want on the area is the 240 degrees. So the area of the sector, this regular sector, is the central angle over 360 pi r squared. Write down the formula. Helps you memorize it. The central angle we want is the 240 over the 360 times pi 3.14, and our radius is OW, which is 6, so 6 squared. And zeros cancel. 12 into 24 goes 2, 12 into 36 goes 3. So we got 2/3, 3.14 times, 6 squared. The radius is squared. So 2 divided by 3 times 3.14 times 6 squared, or 36, and that comes out to be 75.36, and we want it to the nearest tenth, so 75.4, and it's meters, so it's meters squared. Again, the 3 is in the tenths place, so this digit is greater than 5 or greater, so we add 1 to the 3, so we get 75.4. And that takes us to the end of the video on finding the area of a sector of a circle. Hope you enjoyed the video, and if you did, click the like button, click the subscribe button if you're not a subscriber, and the notification bell because more videos are coming. And if you're a subscriber, write a comment on my video. And you may also visit my math website at mathfullyexplained.com to find information on me, the videos, the teaching styles I'm going to use to help you learn your math, and the content that's on my YouTube channel. Thank you very much. Bye-bye.